Okay, in this video, we're going to pick up where we left off last class. So the unit circle means that the radius of the circle is 1. So remember where we had R right here, we now have number 1. This has an impact on all 6, well, I should say 4, of our trig functions. So wherever I had the R, I'm now going to replace it with a 1. So what happens when you do that is sine of an angle is just y. Y is the y-axis value. Okay, cosine is just the x. Tan is still y over x, but now you can think of it as tan equaling sine over cosine. Here I'm going to replace 1 again, and cotan, you can think of it as equaling cosine over sine, which will help us later on. Okay, so that's one takeaway from the last class. So let's continue. Another takeaway, remember we built with special triangles the first quadrant of the unit circle. Okay, so we went over that. This is where the unit circle comes from, and the unit circle will be very much your friend for the rest of this unit. So what I want to do for you in this video is to build the unit circle, and I'll show you how I do it. Okay, so first off, you have degrees and you have radians. So let's just go around, and what I'm going to do is the following. All of the 30 degrees and variations thereof, I'm going to make green, and this will be apparent in just a second. So here's 30 degrees. Okay, here's 30 degrees if you put it in the second quadrant. Here's 30 degrees from the x-axis if you put it in the third quadrant. And here is 30 degrees from the x-axis if you put it in the fourth quadrant. Okay, so that's one thing. Okay, so then I'm going to do all the 45s. I'm going to do them in kind of a pink color. So in pink, here's 45. Here's 135, which is 180 minus 45. So that's your tip off there, that they're going to be the same values for sine, cosine, and tan, at least the same absolute values. Here's 315. Okay, then we're going to go into the 60s, and they'll all be blue. Okay, so here's 60. Here is 120. Here is 240. And here is 300. And here is, we're done. Okay, so then we have, what else do I have? Oh, then I want to do the quadrantal angles. I'm going to do those kind of in orange. Here's a quadrantal angle. It's right here. Another one on the vertical is the 90 degrees. Another one is the 180. And another one is the 270. Okay, so now we're going to put our degrees in radians around the circle. And I'm going to show you how I count that. Okay, I'm going to first off do the 45 in radians, which is pi over 4. I'm going to do that separately, and I'm going to show you how we're going to do that. That's going to be in red. So this is 1 pi over 4. Okay, go to the next red, and that is 3 pi over 4. See how they're all odd numerators? Then down here, we have 5 pi over 4. And lastly, we have 7 pi over 4. Okay, so they follow their own pattern. It's all odd. Pi over 4 is really 1 pi over 4, so you've got 1, 3, 5, and 7. Okay, so we're going to let you use a unit circle when you do your work, so you don't have to build it, but at some point you may have to build it, so that's why I'm kind of going around like this. Okay, next thing we're going to do is in green, I'm going to count all the pi over 6. I'm going to count a lot more than I'm going to end up with, and I'll show you why. Okay, this is 1 pi over 6, skip the 45 degrees, the pi over 4, and then this is 2 pi over 6. Here's 3 pi over 6. Here's 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. And this is going to be 12 pi over 6. All right, so they're all green, but now comes the change. Wherever I can reduce, I'm going to reduce. So let's start reducing. I'm going to change color as I do. Okay, 2 pi over 6, I can reduce that to pi over 3. So I made it blue. Okay, so then we have 3 pi over 6. I can reduce that to pi over 2. Pi over 6, right here, can be reduced to 2 pi over 3. 5 pi over 6 stays. 6 pi over 6, which is a quadrantal angle, can be reduced to just plain old pi. 7 pi over 6 is fine. 8 pi over 6, that can be reduced to 4 pi over 3. 9 pi over 6, another quadrantal angle on the quadrant. That's going to now be reduced to 3 pi over 2. And then 10 pi over 6 also can be reduced. Okay, 10 pi over 6 can be reduced to 5 pi over 3. Everything else holds up to the 12 pi over 6. Which can be reduced to 2 pi. Okay, and I should have put this as 360, and this is also 0. All right, so now we have all of our angles, both in degrees and radians, in the best form possible. Next thing we're going to do is do our counting to get my coordinate pairs outside. Those are my terminal points. So I'll show you how we do that. So I think I'm going to do them all in black, just to make life easy. So all in black, I start from the outside, and I go 1, 2, 3, 1, 2, 3. Divide everything by 2, and take the square root of the numerator. And since the square root of 1 is 1, I'm going to leave it be. Now I have all of my first quadrant angles except for the quadrantals. The quadrantals, let's fill those in now. This is 1, 0. This is 0, 1. Remember, these are x and y's, and this is a point on the unit circle. This is 0, 0, so just from the origin. This is negative 1, 0. And this is 0, negative 1. Okay, when I give you a unit circle to work on, or to work with, it's going to look like this. This is what you're going to be given. Just for our exercise in symmetry, I'm going to fill in the rest of this, and I'll show you how I'm doing it, so that you can just use the first quadrant and not have to have all the rest filled in. So I'll show you why. Okay, so let's look at all the green angles. So that's all the pi over 6's. So look for a denominator that says pi over 6. So 5 pi over 6 is going to have the same 2 values for x and y. But what's different about them? Well, in this second quadrant, the x is negative, so that becomes negative. Okay, look again for another pi over 6. 7 pi over 6. So 7 pi over 6 is going to be the same absolute value. So this is radical 3 over 2 and 1/2, but now they're both negative. Look one more time. 11 pi over 6 is another pi over 6 multiple. So therefore you're going to say, okay, same absolute value, radical 3 over 2 and 1/2. And in this quadrant, the y is negative, so that becomes negative 1/2. Okay, let's go through the pi over 4s. So anything with the denominator of the radian that has a denominator of 4, we're going to do. Okay, so I get 3 pi over 4. Same absolute value, but in the second quadrant, the x is negative. 5 pi over 4. Same absolute value, but in the third quadrant, excuse me, they're both negative. Next one, 7 pi over 4. Same absolute value, but in this quadrant, which is the fourth quadrant, my y is negative. Done. Okay, we have one more round to go, and that's all of the pi over 3s. So 2 pi over 3, and I'm focusing you on the radians. That's the key to success on this. So focusing on the radians, the pi over 3 is going to have the same absolute value, the coordinates will, as 2 pi over 3. So this is going to be 1/2 radical 3 over 2, but because I'm in the second quadrant, my x value will be negative. 4 pi over 3, I'm going to have 1/2 radical 3 over 2, but in the third quadrant, both of those are negative. Last one, 5 pi over 3, and that's going to be 1/2 radical 3 over 2, and in this fourth quadrant, your y value is negative. So remember that these are the quadrant numbers, 1, 2, 3, and 4. And our little way of remembering what's positive, everything's positive here. All students, only sine and cosecant is positive in the second quadrant. Take, tan and cotan, positive in the third quadrant. Calculus, cosine and its partner secant are positive in the fourth quadrant. Okay, so that gives you an introduction to how I'm doing the unit circle. Okay, here's another copy of it. Okay, so now we're going to do something else. We're going to say, remember the formula for the arc length. It was S equals R times theta. And so S was the arc length. R was the radius. And theta was the angle. Okay, so since the radius of our circle is 1, we can simplify the formula above by no longer including the r, and so the arc length will equal the angle in question. So going forward, we're going to use the variable t to represent the arc length. So notice that t, therefore, is both the arc length and the angle. Okay, so let's look at the first drawing. It says t indicated in the red below is the arc length and also the angle on the unit circle. So this angle began to open here and then it ended here. All right, so this is the angle that opened. So this is your angle. This is your arc length. Remember, they're one and the same. And this right here is your terminal point. And remember, your x and y are also in alphabetical order, cosine and sine. All right, so that's one thing. Look at this next one. If t is less than 0, that means that my angle must have opened down. That's your terminal side. That's your angle. That's your arc length. They're one and the same in a unit circle. So then we go on to tell you, in all cases, our arc length or the angle ends at a terminal point of PXY. And that's what I've been doing. I've been giving you these terminal points. Okay, so this one's going to be a right angle, isn't it? So that's 90 degrees, or pi over 2 for both your arc length and your angle. Okay, next one. This is a line, right? A line has a degree of 180 or pi, and that's the same for the arc length and the angle. So going forward, they're going to stop using this and start just using t for the actual angle. All right, next thing. Now you have to talk about, we're going to talk about a concept called reference numbers. Reference numbers are also called reference angles, and I will probably call it reference angle because I prefer that. So I'm going to be saying reference angle a lot. The textbook uses reference numbers. They are one and the same. Okay, look at these acute little angles. These are bow tie angles. Remember that in the first quadrant, your T, which is your actual angle, is going to be exactly the same as your reference angle, which is T bar. In the second quadrant, your T right here is the actual angle, but we're going to tie it into the reference angle, which is T bar. Okay, so keep that in mind. So that means to figure out your terminal point and to figure out these signs, you're going to use your reference angle coupled with the fact that it's in the second quadrant. Here's your reference angle or reference number right here. Notice that angle is always the shortest distance from the x-axis to the terminal point. That's how you get your reference angle. Shortest distance from the x angle to the terminal point. That's your T bar or your reference angle. Here is your T, which is the actual angle that you're talking about. Last quadrant, here's your T, which is your actual angle, and here's your reference angle, which is the shortest distance from the terminal point to the x-axis. Okay, so T bar is always an acute angle from quadrant 1. Okay, so T bar is called your reference angle or reference number. Okay, this ties into how we're going to use our unit circle. So, if you're going to use your unit circle to find the terminal point for each angle T below, this is what you're going to do. Now remember, the terminal point is your X and Y, okay? And then I'm going to say the signs must reflect the quadrant. I'll tell you what that means in just a second. Okay, so if T equals 5 pi over 4, what is your reference angle? Your reference angle is going to be pi over 4. Okay, this is infinitely easier in radians. Pi over 4 is your reference angle. Okay, what's your terminal point? Well, I know that my reference angle has these X and Y values, but now where is this guy located? Let's go back to the unit circle, and 5 pi over 4 is right here. Okay, so it's right over here in quadrant 3. In quadrant 3, both the X and the Y are negative, so therefore, when I come back here, I'm going to make that change. This is the actual terminal point of that angle. It is in quadrant 3. Knowing the quadrant is going to help you tremendously. Okay, if your actual angle for B is 11 pi over 6, then your reference angle is going to be the angle that relates to that in the first quadrant, which is pi over 6. Okay, let's go find the reference angle because I need to figure out a whole bunch of things. So coming back here, 11 pi over 6, here is my angle. Okay, here's my reference angle. I see the values are root 3 over 2 and 1/2. And because that 11 pi over 6, the actual angle, is in the fourth quadrant, this is what's going to happen. So this is in the fourth quadrant. So I knew that it was radical 3 over 2 and 1/2 for the reference angle. But in the fourth quadrant, the y is negative. Done. Okay, if t is 4 pi over 3 for C, t bar, or the reference angle, is going to be pi over 3. I happen to know that pi over 3, the coordinate pair, is 1/2 radical 3 over 2. Now the question is, where is 4 pi over 3? Let's go look. Okay, 4 pi over 3 is right here. Okay, since it's right there, and it's related to this angle that I recognize, and I already knew those. So in the third quadrant, what do we know? Well, this is quadrant 3, which I'm going to always write down to help myself. That makes both of these negative. Okay, that's the kind of stuff you're going to have to do. Now notice I didn't read the entire unit circle. I only read the first quadrant values, and then I put the signs on accordingly. Okay, this next one says using the unit circle you just completed, find the terminal point on the unit circle determined by each real number t. Hint, feel free to go coterminal if you wish, and I do wish. Okay, if this angle is negative pi over 4, can't I add 2 pi to it to get my value that's on that unit circle? So add 2 pi. Okay, just planning ahead. If I add 2 pi, isn't it better to add it as 8 pi over 4? Because then I can actually get the value, which I know is 7 pi over 4. So now what do I have to do? I have to find the coordinate pair, which is the terminal point. So I know that all of the pi over 4s, so t bar is going to be pi over 4. I know that all of them have the exact same values. So then the question is, where is this angle? Where is 7 pi over 4? Go back to the unit circle, figure out what quadrant you're in. So what quadrant are you in? 7 pi over 4. You are over here. And in that quadrant, my y is negative. So come over here and say, okay, those are my values, but my y is negative, and now I am done. Okay, next one. 8 pi, 8 pi over 3 is also too big. So let me change color. So 8 pi over 3, oh, and by the way, t bar is going to be pi over 3. So pi over 3, I happen to know, has values of 1/2 and radical 3 over 2. But I'm not quite done because I'm not sure what quadrant 8 pi over 3 is coterminal to. So I'm going to subtract away, because this is too big an angle, subtract away 6 pi over 3, which is 2 pi. That gives me 2 pi over 3. Find out where that angle is. 2 pi over 3. 2 pi over 3 is right here. That is in the second quadrant. So in the second quadrant, what do I know? I know that my x's are negative. Boom, I'm done. Okay, next one. So with this next one, t equals negative 5 pi over 6. I know my reference angle is pi over 6, And I happen to know, if I look back, and you can look this way as well, let's look what I have for you. If I look here, what do I know about pi over 6? Here are my coordinate pairs right there. So I'm going to come back up here, and I'm going to write down those coordinate pairs, which were radical 3 over 2 and 1/2. Now, I have to figure out, where is this angle? Negative 5 pi over 6 is off my unit circle. So I'm going to add 12 pi over 6, and that gives me 7 pi over 6. Okay, what quadrant is 7 pi over 6? So 7 pi over 6 is right here in the third quadrant. And in the third quadrant, as I go back, I know everything is negative, so therefore both of these are negative, and I'm done. Okay, so let's keep going. Now they have you identify the quadrant where t resides, use your unit circle to find the terminal point for t, and use your knowledge of trigonometric functions to find the requested value. So that's down here. Okay, so what will I do here? I'm going to say 11 pi over 6. If I look back here at this unit circle, I see 11 pi over 6 is right here in the fourth quadrant. And I see that pi over 6 has those values, root 3 over 2 and 1/2. So come down here, indicate, I'm up here, indicate where that angle is, and it's over here, right? So that's my terminal value. From here all the way around, that is your t. What is your t bar? Your t bar is your reference angle, which is pi over 6. That's where I got the values root 3 over 2 and 1/2. But in the fourth quadrant, the y is negative, so that's my appropriate pairing. Sine of 11 pi over 6 will be negative 1/2 because sine is a second value. Okay, I'm going to quickly go through the rest of these. So 5 pi over 4 is going to be in this quadrant. Opens up to there. Your t bar is pi over 4. Therefore, I know that my values are this in the first quadrant for t bar, but in my actual quadrant 3, they are both negative, and cosine is the first. Done. 2 pi over 3, I know that my t bar is pi over 3, and therefore I know that my values, looking at my unit circle, are radical 3 over 2 for the y and 1/2 for the x. This angle is actually here, so that's where my t is. So it's in the second quadrant. In the second quadrant, that is 1/2. It's negative. So I'm going to say the sine, therefore, remember the pairing is xy or cosine of the angle, sine of the angle. So sine is going to be the y value, which is root 3 over 2. And then quickly doing these, what's going to happen here is I'm going to have to get this back on the unit circle. So I'm going to add 8 pi over 4. I therefore realize that the coterminal angle is also the t-bar angle. And so that makes this easy because that's just root 2 over 2. They're both positive, and therefore the tan, which I know is sine of the angle over cosine of the angle, which is going to be, remember the x, the y over the x, and they're both the same, so it's just going to be 1. Okay, and one last one. If I'm going to have my t is 10 pi over 3, that's also too big. I'm going to get that back on the unit circle by subtracting away 1 full 2 pi. That gives me 4 pi over 3. Looking at my unit circle, I see that's over here. My t bar is pi over 3. I look up my t bar values, and I get 1/2 and root 3 over 2. But since the actual angle is in the third quadrant, they're both negative. And asking for cosine, cosine is the first value, so that's going to be negative 1/2. Okay, this is the unit circle we're going to use. Don't use the completed one to do this homework. Use this one. And that's it. Thank you so much. Hope this helped.